essentially, here's a little bit about me, right? We're going to talk about Windows, privilege escalation and pivoting inside of Windows environments and Active Directory. My name is Sam. I'm a penetration tester. I've also worked as a security administrator. I have a master's degree in information assurance and computer security. I have a CISSP if you're into that sort of thing. I have a lot of experience in the payment card space, but a bunch of other verticals as well, like healthcare, and I've worked with like manufacturing industries and things like that. My opinions in this talk are my own. They're not representative of my employer, and the purpose of this talk is just purely for education. So my main point here with this comment is just to say hacking networks is illegal last time I checked, so don't do it unless you have permission. What to expect from this talk? I just want to lay some ground rules and sort of get into what we're going to talk about. This presentation is not about exploiting networks. It's not about leet hacksoring, and it's not about finding sensitive information inside of environments, right? It's sort of about the middle part of hacking an environment, right? This idea of you've gained access to an environment and you're trying to get some data or you're trying to accomplish some goal. How do you go about that? Where's the middle part? How do you move through that environment? How do you gain additional privileges so that you can keep moving deeper into the environment until you accomplish that goal? So we're going to talk about privilege escalation after an initial compromise. We're going to talk about abusing configurations, right, and features inside of Active Directory. And we're going to talk about baselines for attacker capabilities. So when I say that I don't want to talk about really elite hacking, what I mean is a lot of stuff I'm going to talk about in this talk are things that you can do rather simply and things that attackers can do with fairly minimal effort. And I think that that's important because it lays out, again, this kind of baseline of what attackers are able to do, and it sort of establishes this idea of, this is sort of what you're up against, right? So we have some assumptions here. An initial system has been compromised, right? We're not talking about how you got on that box. We're going to assume that an attacker has gained access to some system in your environment via, say, phishing or, some kind of drive-by download or something like that. And then we're going to talk about these tools that are in here. I don't want you to really focus on what the tools are. The demos I have use PowerShell, right, which leverages .NET and things like that. But realistically, you could use any kind of tool to do this, right? Or you could use other tools to do it. You could write your own. So I don't want you to really focus on oh, well, these are just PowerShell tools that we can lock down PowerShell and this isn't a problem anymore. So why do we want to talk about credentials and credentials in an environment? And I think, one of the things that when you first get into hacking and learning about computer security, I think everybody gets really excited about exploitation and, sort of memory corruption and all those sorts of things. But really, I view, exploits as sort of a last option, right? There's sort of this noisy thing that you don't want to use unless you have to, right? Ideally, attacking an environment and looking for information, you typically, credentials are really cool because they don't get flagged by antivirus, right? You don't get in trouble for logging into something. Actual exploit, you can end up basically getting flagged by AV, so you've alerted your organization that you're attacking, that you're doing something. They can also impact system stability, right? Maybe they just mess up something in memory and the system maybe it crashes on the spot, or maybe it seems fine and then it crashes later, right? The other thing about using credentials is you can blend in, right? You're using existing credentials. Most companies trust their users or place at least some level of trust in their users, right? So you can have somebody from the accounting department and they're just a stand-up employee, they're not doing anything wrong, right? But you can't really trust their account at the end of the day. That account can be compromised and it can be basically turned into a malicious insider without that employee's knowledge. So that's one of the things I think are kind of cool about using credentials in general. Right, so I wanted to take a moment here to just talk about the flow of this talk and the sort of things we're going to cover. Attackers, as I said, they have goals, right? They want to get some kind of data or exfiltrate something or, gain some kind of secret or something like that, right? And there's this piece in the middle where you have to move through an environment because you typically don't land on the endpoint that has the data you want to take or the sort of goal that you want to access, right? So you got to move through an environment and gain additional privileges until you can get what you want. Right, so what happens is you start out with some kind of local access. In this case, we'll assume some kind of limited local access, like a standard user account. And you move through and you try to get, say, admin access to a workstation because you're able to gather additional credentials and additional information that you can use to pivot further into an environment. And as you get further into an environment, you kind of do this check every time, right? You say, can I get the information that I need right now? Well, no. Well, okay, I want to try to escalate privileges on this system so I can get additional credentials, or maybe I want to take credentials that I've gathered here and try them on other systems. And that's what this talk is mostly about, right? And sometimes that involves escalating all the way from, like, say, a standard admin on some system into, other systems where you have admin rights, and ultimately to, like, domain admin access, but that's not always necessary. But those are the kind of different levels of access that we're going to talk about today. Just a little bit of details I want to cover about the lab environment that I use to sort of do the demos for this talk. It's just 4 computers that I laid out so we can kind of talk about different levels of access and different systems, right? To just give some way of showing that they can all interact with one another. You don't have to, like, be hyper focused on what this looks like, and if you're, if you don't remember it, it's not going to ruin everything for you. But we have an Active Directory domain controller, right? It's called DC1. We have a file server. It's called FILESRV because I'm really creative with names. It's got a file share there. You can see that by the hard drive, and it's got a database running on it, right? Like a SQL server. We'll talk about that. We also have a user's workstation. It's called Win7 User, and that's just like a standard domain user's workstation, right? Maybe somebody from accounting or something like that. And we have this admin workstation, right? Win7 admin, and essentially that's just where your admin is working, right? They're a domain administrator, and they're doing their day-to-day work, like trying to, keep the company running and make sure everybody can do their jobs and so on and so forth. Here we have just a little bit of information about user accounts. I have a bunch of, like, randomly generated accounts in the environment, but these are the ones that we really care about. We've got, like, an administrator account, right? The REDLAB administrator. It's just a built-in domain administrator account, and it basically has the keys to the kingdom, so it can do whatever it wants, or it can give itself the rights to do whatever it wants. And then we have Alice admin, right? She's a domain admin as well, so she has the same rights as that built-in administrator account, but she's working on that Win7 admin workstation. And we have T user, or Tim user. He's a domain user. He has just a standard domain user, and he is on the Win7 user box. And then we have this REDLAB SQL service. And basically that just represents a SQL Server account, right? Like, so some kind of service account. And typically what you find is people will give those domain admin credentials. So we see that pretty regularly. So I thought that'd be an interesting thing to include. In this case, just for simplicity, I put that on the file server as well. So as far as privilege escalation is concerned, right, we're basically looking at different paths through this environment, or different means to gain further access to the environment, right? That means, again, like some kind of credential harvesting, right? We're looking for maybe like shared passwords. So we have 2 users, you can get their email and you find out that there's some shared account that these 2 users are passing the password back and forth via email or something like that. Maybe that account is valuable to you and maybe you can use it to move further into the environment. Another thing is like stored passwords, right? Maybe you can get into a configuration file and you can find an account password that's useful there, right? That gives you additional credentials. The other thing is, there are easily guessable passwords, right? If you have enough users in an environment, you typically can start finding useful passwords, or useful accounts with like basic passwords like winter 2018 and things like that, right? If you have enough users and a sort of weak enough password policy, you can start to find stuff like that pretty much all the time. So, and then there's this issue of like password reuse. As you gain access to different passwords, as you learn about passwords in the environment, you can take those and try those against other accounts, and you'll find that accounts have the same password, right? So they're like popular passwords in environments. And basically, again, kind of as we've touched on already, there's this idea of like this privilege escalation process looks like you want to get some kind of like, administrative or system level credentials on a system so that you can, or on a workstation so that you can steal better credentials or the data that you need. Or you want to move on to the network and you want to find another workstation where you can get that same level of privilege so that you can steal, better credentials to get to your end goal. So right now we're going to start out, we're going to talk about initial access to the environment, right? This is that first workstation you get access to. Win7 user, we're a non-admin user, and we're going to start talking about sort of different attack paths, right? When you land on a box, or when an attacker lands on a box, basically they'll start looking for like situational awareness, right? And just trying to figure out who they are, like what is the sensitive information they care about there? Well, no, okay, let's try to see what privileges we have on this box and sort of what level of access our credentials have, right? And then if they can't get the information they need on that box, they start to look to the network, right? They start to look to network shares, and they start to look to printers and Active Directory and other types of services. So we'll talk about kind of all those things as we move through this. Excuse me. So here is just an initial idea of, right, like when you land in a box, things you might want to look at initially is just like, who am I, right? Like it tells you what user you are. In this case, like the test user account. We use net user, right, to give detailed information about that user account, and we can use like net local group administrators to see if we're a member of the local administrators group. Let me see if this is going to play by itself. Okay, cool. You guys get to watch my really slow typing. So here's who am I, right? We get to find out that there's T user, right? We can do net user, and what we see here is these are the local accounts. We have an administrator account, and we have this Chad user, and we have a test user, right? And then you can say net user T user / domain, and it gives us our domain group membership, right? So we can see here that that is a domain user. So at this point, we kind of know what rights they have on the domain. We know they're not a domain admin. And you can do net local group administrators, and you see that the domain users are not a member of the administrators group, right? So that's important because we know kind of the level of access we have to this box is just that of a standard user at this point. So local escalation, you kind of have a bunch of different options here, and some of them are kind of basic and just different things that you'll sort of see crop up in different environments, right? One of the things is unattended install files. So there's this issue of like when you have to roll out, say like 2,000 or 300 workstations or whatever, they do automated installs, and there's this unattended.xml file that sometimes, if you're not paying attention or you're not keeping it clean, you can actually end up leaving that on your systems when it rolls out, right? So you can have a bunch of workstations out in an environment that all have the password that's used to like join all these boxes to the domain, right? And like set up the local administrator accounts. So I found that before, right? There's this issue of automatic logon. This one's a little bit more rare. And what that is there's a registry key listed right there that you can use to automatically log into Windows. Like, so if you need Windows to boot to some like specific desktop and then say like launch like a program and just run that as its GUI, that's kind of where you do it. And you put a password in there, and it's stored in plain text in the registry, and that's just like, for the most part, the way that people do automatic logon on Windows. There's another option called always install elevated, right? This is to fix an issue of people needing to install software, right? So what happens is if you have like an MSI or something like that, you can tell Windows like, well, always escalate privileges for that process, and it'll do so. So then you can make a malicious MSI that really just like actually say runs a command to add a user or something like that to the box. Other things that are kind of interesting are like webdeck config strings and stuff like that. So if you have like an IIS server or something like .NET running, you'll find that you'll find passwords and configuration files in there, so you can actually pull those. Sometimes they're encrypted, and sometimes you're able to decrypt those. You'll find like straight up config files, right? Like VNC and stuff like that have easily reversible sort of password encryption in their config files, right? So you can actually grab those and decrypt them. And you'll also find sometimes programs like that just have plain text user credentials in them, and those can be useful to you on the domain or on other systems, or maybe even to just get into, some other resource. There's also like modifiable scheduled task files, right? So like the configuration for scheduled task file might be something you can modify to suit yourself, or you can gain further information from. One of the things I want to talk about today, though, is because we can't really cover all of these, because I could probably stand here for 2 hours and talk about just this slide if we wanted to, is unquoted service paths, right? And this idea of DLL hijacking sort of ties into that. And then we'll talk about something called group policy preferences. These two are kind of interesting, I guess, for our purposes right now. Unquoted service paths is essentially this idea of like file permission based privilege escalation, right? So we're looking at file permissions on the system and the way that like Windows actually loads, loads services and runs things, and also loads DLLs. So if you look at, this is gonna be hard to see from the back, but if you look at the way that service paths work, so we have like a service. Over here on the right, on
on your left, you'll see that we have like a VMware service, right? And if you see, it's like launching out of C://program files, right? And there's this path, and it's quoted. It's got double quotes around it. And that's actually really important because Windows views this space in that file, in that path, as a separator. So what happens in this case, right? This Realtek USB is actually really reliable for this. It never quotes this. I've never seen a computer where this is quoted. And so what'll happen is if you're able to write an exe to the root of the C drive that's called cprogram.exe, where that space happens when it tries to load that file, that service right there to run, it's actually going to run program.exe if you can write it. Now, if the file permissions in Windows are set up correctly, that's not going to work, right? Because you're not, as a standard user, you can't really write program.exe to the root of the C drive. But I guess it's worth illustrating because we can talk about cases where it will work. So here you'll see some examples of where you might be able to, say in that contrived example, write an exe. C:program.exe or C:program files x86, Realtek US, and then there's this other directory, it's USB space something, you could do usb.exe there. When you reboot or when the service starts, it will throw an error, but users can click through that, and if they do, it will run. This has been known about since 2012, and it hasn't been fixed. Essentially, Microsoft has said this is a best practice, like everybody should just be putting double quotes around their service paths, right? So standard users, as I've said, they can't write to program files in those instances, right? But there's this kind of interesting thing that happens with permissions on Windows systems. So by default, when you look at something like program files, essentially all of the sort of directories that you're used to on the root of Windows, like program files and users and stuff like that, will have read, execute, list folder contents, and just the read permission itself set, and so you can't actually modify those, right, as a standard user. But if you have some kind of third-party program installed, right, and it installs itself to the root of the C drive, it sets different permissions. So what you end up with is, you end up with these permissions. You have modify, you have read and execute, and you have write, right? And you have like a list folder contents and some other things, right? So in this case, and this is a permission that's set for all authenticated users. So if you're able to log into that box, you can actually start to write files, right? So in this case, we have a path called C:3/party program. So the second folder is called party program. If you can write inside of third, if you can write party.exe right there, and there's a service that that launches that with an unquoted path, you can cause it to sort of choose party.exe and run whatever your malicious binary is, which is kind of interesting. At least I think so. There's another issue of group policy preferences, right? Group policy preferences is an old way to set an administrator password or a single password throughout an environment, right? So if you needed to set all of your desktops to have like a shared password, right, for like break glass situations where you need to let your administrator log in, that's one way to do it. Group policy preference has been around for a long time, and essentially back in what they did is they'd encrypt it inside of the group policy object, right? There was this AES key that was used to encrypt whatever password you put in there. So it was pushed out to workstations and it was encrypted, and it all sort of seemed really safe, right? And then back in 2012, Microsoft accidentally published that AES key, and that's right there. And you can actually still go to the Microsoft website and pull it down at that link. The AES key's there. So that's kind of interesting, right? So for a couple of years, attackers were just able to do that, right? Like if you did this in your environment, if you set your administrator password via group policy preferences, an attacker could just simply pull this down and decrypt it, right? It was really easy because all of your group policy files are on the sysvol of a domain controller, and they're all readable by everybody who's in your environment. Like every single domain user can read group policy. So what happens is finally in 2014, Microsoft patches this, right? They roll out some patches, and basically that kind of fixes the problem. But what it really does is it just prevents admins from doing this anymore, right? Like it just says, hey, you can't set the password via group policy preferences. It doesn't remove the old password if you already have it there, right? So it's still in your group policy, and it doesn't actually make you change it on your endpoints, right? So you have this issue of, well, maybe they didn't actually rotate the password, right? So maybe an attacker can still find it and can still use it. The other thing that's kind of interesting about this is maybe that's not the case. Maybe they rotated it, right? But maybe you can take that password and find somewhere else, another account that they used it for, right? Because sometimes, at the end of the day, like, admins have a lot to do, and maybe they have like a default password that they set stuff to, right? Like, I think we've all kind of seen that, or maybe we know people that tend to set, you know, the same password for a bunch of different accounts. So there are some things you can do about this, right? One of the things is Microsoft's local admin password solution. It's called LAPS. It's something that they rolled out, and basically it's a way to set a single account password throughout an entire environment. And you can name an account, you can say the local administrator account or whatever, and you can say, I want all of these accounts to have like 12 character passwords or whatever, and it will randomize passwords for you throughout the entire environment. And you can say, I want them to rotate every 90 days or whatever you need, right? It'll set them all for you, and it will store them in Active Directory inside of a computer object, right? So every computer object in Active Directory now has a unique local admin password, right? It's stored in plain text, so that's a bit of a caveat, I guess, maybe an issue for some people, but you can delegate access to it. So you can say only people from help desk can get access to, you know, these desktop ones, and you can log it. So you can say, well, Steve from help desk, you know, just pulled up like 300 of these, like maybe we should alert, you know, or care, right? Or, oh, he pulled up one because he had to fix something, right? It's still a win for defenders, right? Because if someone's attacking an environment, and say I'm attacking an environment, I gain access to one sort of local admin password. If it's only good on the workstation that I'm on, and I already have, you know, that level of credential, I don't really gain anything, right? Like, I can't move to another workstation. Versus if all 300 of your workstations have the same password, suddenly I can start moving and gathering additional details, you know, using that. So I think that's really cool that they actually rolled that out. And the last thing I want to talk about as far as local privilege escalation is this idea of there's a PowerShell script called PowerUp, and it's part of PowerSploit. And there's a bunch of PowerSploit tools that I actually use throughout this talk. PowerSploit is basically offensive PowerShell, right? So it's like people making PowerShell attack tools. And there's some really, really neat stuff. PowerSploit does a lot of the checks we just talked about, right? Like even the stuff that I kind of glazed over, it does a bunch of those, and it does more, and it does them really quickly, right? Like you don't have to know what you're doing really or anything, right? Like it can just do it. So something you might want to consider just running against, say, your images before you roll them out to an environment to see if, oh, are we sending out an image to all of these workstations that happens to, you know, have a problem, right? So in this case, like we found, so it does like the unquoted service paths thing, and it looks for always install elevated, right? It looks for auto logon credentials in the registry. It looks for an issue with McAfee's site list.xml configuration file. Yeah, it looks for a bunch of other stuff. Here in this case, it found group policy preferences because I had that set. One sec. So let's say you're not able to escalate privileges locally, right? To get to like whatever you care about, right? So you can start to look for admin on other systems, or you can start to look for shares out in the environment that have maybe useful information, right? Files with sensitive information, files with credentials, and so on and so forth, right? So we start to look for shares throughout an environment, again, abusing sort of the credentials that are there. And one of the ways to do that is to, you know, start to use PowerView Share Finder. Again, this is part of that PowerShell attack tool set. But Share Finder will basically go and it'll enumerate all the computers in Active Directory, and then it will look at all the shares for you and tell you what shares exist, right? So you might be able to find things, again, like you might be able to find unintended install files. You might be able to find like a KeePass database, right? KeePass is something that's used for storing passwords and sharing them between administrators. If you can find a KeePass database, you can actually feed that to like a password cracking tool like Hashcat, and you can try to crack that. So that's kind of a cool thing. You know, other stuff like that. Again, you might find other configuration files that are interesting, but here we'll just do a quick demo of invoke Share Finder. And what that'll do, all it'll do again is just give you a list of all the other workstations, and it'll tell you what those shares are. right? The next thing we have here is called find local admin access. It's kind of a sister program to invoke share finder, right? This looks for local admin access. It pulls down, again, all of those computers in Active Directory, and it tries to authenticate each of them, and it says, hey, are you a local admin? Well, in this case, it came back with one where it said, hey, on FILESRV, my user, T-user, is a local admin, right? And if we go to FILESRV, which is this window on the bottom, and we do net local group administrators, we found there's a misconfiguration. Somebody made domain users like a member of the local administrators group, right? So suddenly we have increased credentials on that box or increased privileges on that box, and we can start to sort of get into more nefarious activities, right? And trying to gather additional credentials. One of the things that's kind of interesting is if you can't get admin access to something, right? Maybe you have write permission to some share. You know, maybe it's like there's a share that like people in your department go to, or your user's department, or that IT might go to, right? And you can actually write files to that share, and you're still a limited user, but you can create files. So this is the leadest thing in this talk because it required me to use a hex editor. I think there are other ways to do this, but I did it in a hex editor. Basically, you can take, there's a LNK file, which is basically just like a shortcut file, right? Like a link. And you know how files all have the little thumbnail, right? That gives you a little image of what the file looks like, or the little icon. I made a LNK called Sneaky Link, and basically I changed its icon so that it points to a Windows file share, or what's called a UNC path of my choosing. And I said, well, the image file is on this share, right? So what happens when a user goes into this folder, when they descend into the share that you put this on, their computer, without them even clicking on it or trying to follow this link, is going to go, oh, well, here's a whole bunch of files, right? Oh, I got to Sneaky Link, and I want to display the thumbnail. And it's going to go try to authenticate to that share, right? It's going to send a net NTLM hash, and it's going to actually try to log in to get that image, right? And it doesn't matter if it fails at that point, right? Because you've just captured a credential that you can try to crack or something, right? Or maybe you can relay it to another system. One of the other things that's interesting here, pardon me, is in this environment, like here I pointed it at like a local system that's inside, right? If the organization is not filtering like SMB out to the internet, right? They're not blocking like Windows file sharing to the internet, you might be able to actually point it at, say, a file server on the internet, right? Or a listener on the internet. So suddenly everybody who goes to that file share is sending their domain credential, this hash anyway, to the internet. And then if you're able to crack that, at that point, you can potentially use it to maybe get into their VPN or their SharePoint or their OWA or something like that, you know, if they're not using two-factor or something else to sort of mitigate that risk. So, and we'll circle back to this. I didn't do a demo of this. I sort of did a roundabout demo of it that we'll touch on a little bit later. The other piece here is you can start to look at other network devices, right? Things like printers or other systems that have default credentials. Printers are actually awesome. They've worked out really well for me in the past. So many environments have like multi-function printers, right? So the printer, scanner, copiers, these huge things like, you know, Sharp printers that have passwords of like admin and Sharp, right? Or admin. And you log into them and you realize that somebody has configured this printer to be able to scan, you know, PDFs or something to a share so that their users can get these PDFs of documents that they've scanned and, you know, and do their job, right? But they didn't really think about that. So if you can get into systems like this that have that configured, you can often take and you can change the settings so it points at you, and then you just click the test button. You don't even have to actually modify the configuration, you just test it, and it'll be like, oh yeah, I'll try this. I'll try to connect to you, and it'll send you again, right? Like that hash. So you end up with a credential that you can then monkey with, right? And so in some cases, you might get like a standard user account, right? That allows you to get into something, or maybe they have slightly different privileges. Or maybe I've had cases where I literally was like testing an environment, and I logged into a printer with default credentials, and I looked at the setup, right, for the sort of scanning to a share, and found that it was a domain admin account, right? Like writing these PDF files, right? And it's like, well, there, I can now get into whatever I want, right? And that was like 20 minutes into testing or whatever, right? So you find things like that, or you'll find other systems too that just have, you can log into them and you'll find accounts or credentials somewhere. So that's something I thought was worth at least mentioning because it's kind of one of those things that sometimes people don't think about. So now, still as a regular user, I wanted to talk about this idea of Kerberosting, right? Kerberosting is a pretty interesting attack that I have been using more recently. So as a standard user, you're able to engage in this. And we're going to have to take a quick detour here and just talk about Windows and the way that it stores hashes. Hashes are a representation of your password that's not your password, right? It's like a one-way function. You take your password and you like shove it through this function and it gives you like a unique value, right? So whatever this password is, it creates some unique values here. And there's sort of two main hash types in Windows. There's the LM hash or the landman hash, and there's the NTLM hash, right? I think the NTLM is like new type landman or something like that. But landman was the original sort of Windows hashing method, right? And it was really old and it was really insecure and had a bunch of problems. Like you don't really want to deal with landman if you're defending a network, right? So NTLM is a little better, but it's not salted. But you end up with some interesting things, right? NTLM is basically like the keys to the kingdom in a Windows environment, and they do a lot of interesting things with that hash. So I wanted to just display this hash here. It's represented. This is for the local admin account, which is renamed Chad, and you'll see the LM hash here. And it's kind of hard to see probably from the back, but we have like a colon here, and then you can see this hash value, and then you see the NTLM hash after that. And the first hash value that you see here, if you are watching this later, what you'll find is that actually means that there's no LM hash. Like that particular value means that the LM hash is empty. So now your domain computers have local user account NTLM hashes. So they're stored for those local user accounts, right? Local admin accounts, things like that need to authenticate to the box locally. And your domain controllers have NTLM hashes for all of your domain users because they authenticate everyone, right? So we'll kind of circle back to this, but I wanted to talk about this at least initially right here. So we kind of lay the groundwork for what happens next, because we're going to talk about Kerberos. Here, I'm going to talk about a really oversimplified version of Kerberos. And I actually thought about making this more simple because it almost doesn't even require this much detail. Kerberos is a centralized authentication protocol, right? Like it's a way to have a sort of centralized means of authenticating people, but it doesn't require you to send passwords over the network. It does something using shared secrets, right? So what happens is in a Kerberos environment, you have what's called a key distribution center, right? And that's actually in a Windows environment is your domain controller. And when I want to authenticate to something, right, I can go to the key distribution center and I can say, hey, I would like a ticket granting ticket, right? And it'll give me this ticket granting ticket. And the interesting thing about the ticket granting ticket is that it contains, in its response, there's a portion of it that's encrypted with the user's NTLM password hash, right? So basically at that point, the user account takes its ticket granting ticket and it decrypts that value by providing its own password hash, and then it supplies, the ticket granting ticket back to the back to the domain controller, and it says basically that's how it verifies that it is who it claims to be, without sending its password over the wire, because they have that shared secret, right? That they can both decrypt that to the appropriate value. And essentially, if that's like way too much to talk about on one slide or way too much to sort of conceptualize, all you really need to know is that there's some value in there that is encrypted with the password hash of the user account that is requesting the ticket granting ticket, right? So in our case, in our environment, we have a SQL Server Express instance on FileServ, and it's running with the REDLAB SQL Service account. So that's a domain account. And it gets what's called a service principal name registered in Active Directory. And we'll talk about that in just a second here. Some details about this account are basically kind of what I already covered. excuse me. But again, that's service principal name. And service principal names are used by Windows to basically uniquely identify a service, right? It's within this Kerberos environment, and you can take a service principal name and you can basically get information about the service account without, or the login account without actually knowing the account name. And that's how Microsoft describes that too, right? Like, so if you go out, that's how they explain service principal names. So the important sort of takeaway here is we can request a ticket granting ticket as any user in Active Directory that has a service principal name, right? So any kind of service account that's been registered in Active Directory, you can register a ticket granting ticket. There was a talk in 2014 by a gentleman named Tim Medine where he talked about attacking Kerberos, kicking the guard dog of hell, of Hades, I'm sorry. And he basically laid out this idea, right? Laid out this attack, and it's pretty cool. If you pull down the slides at some point, there's a link to that talk and his slides for that. But essentially, right, at the end of the day, we have a portion of this ticket granting ticket that is encrypted with an NTLM hash of a user's password. So that means if we can guess the plain text password, right, that generates the NTLM hash, right, so we guess the password, we hash it, if we are able to decrypt that portion of the ticket granting ticket with that hash, you've actually just discovered the user's password, right? The target account's password. So you can use that to query all of those service principal name accounts in Active Directory and then perform this sort of attack against them. When this attack came out, it was originally done using Python, right? So like they did all the password guessing using Python. It was kind of slow and really like kind of arduous to use, and your success rate was pretty cruddy. But they've since baked it into tools like Hashcat and stuff, so you can throw like full on like, you know, multiple GPUs at it and really like tear into these accounts, and you don't get like a lot of guesses against them. The other thing that's interesting is when this attack came out, when it was initially announced, it required that you had a local admin on the system where you were going to dump these Kerberos ticket granting tickets, right? It's since people have figured out that there's actually different .NET calls you can make to actually get those tickets without local admin to a system. So even a standard user can basically go out to Active Directory and they can query all of these accounts and get ticket granting tickets, which they can then start to try to crack offline. So I have a tiny demo here, right? Which if you're in the back, again, I apologize. It'll be really hard to see, but essentially, we're a test user here, and we're going to run, again, there's this tool called invoke Kerberos, right? So one of the other things, a sort of theme of this talk, is the idea that like there's a bunch of tooling that exists that like attackers can use, and they don't really have to be all that smart, right? Like the sort of floor to launching like some of this stuff is very low at this point. So we get this hash, right? We get this hash back as part of the ticket granting ticket, and we can take that and we can save it, and we can take it and we can feed it into Hashcat, right? In this case, I didn't use a GPU-based one, but essentially, if we watch this video, what you'll see is I cat out a file with the hash that I just harvested, and then we'll feed it to Hashcat, and it will go through its cracking gyrations. Like obviously, in this case, I used a pretty weak password because I don't want you guys to wait all day for this to happen, but yeah. So once it runs here, it will actually crack that password. And then when you have that password, again, like one of the challenges there is a lot of times SQL Server accounts and service accounts like that end up in the domain administrators group because it sort of makes things work well. It makes things work, you know, it makes things easier. It makes people's lives easier. So sometimes those are really high value accounts that you can actually start to gain access to. And you can do this in an offline manner, right? Like you just grabbed a bunch of these tickets and you cracked them, and you're cracking them offline. So you're not generating a whole bunch of alerts like as you're doing this, right? And then once you have those credentials, you can start to sort of try to move through the environment using those credentials and sort of using their privileges. So here in this case, it found the password. The password is king123. So then at that point, so that's, I guess, one other way to, you know, gain a new credential that you might be able to use to do something else. The other thing I want to talk about here is password spraying. Password spraying is this really kind of thing that's really caught on in the last few years, I guess. everybody remembers like the idea of like brute forcing passwords, right? You take a password, or you take an account and you try to log into it with like 500 passwords, right? Well, eventually people started, configuring systems so that like if you tried to do that, they just lock out accounts. So people switched, right, to this idea of password spraying, where you would take a simple password or a password you think a company might be using, and you take as many accounts as you can, and you try that password against all of the accounts you know of, right? So you generate one failed logon for each user, and maybe, if you know of 20,000 accounts, you're making 20,000 attempts to determine a password, right? Depending, again, it kind of scales with your environment and your sort of willingness to be noisy. But yeah, it's kind of an interesting thing, right? So every single user on an Active Directory domain, as long as you're logged in, you can run netuser/domain, and it will give you a list of every single user on the domain, right? Like, so you don't have to have any special credentials to do that, and you suddenly have, this list of however many users. Again, like if you're in a huge environment, maybe it's 20,000 users, right? Maybe it's 300, it depends on the company. But you get something to work with, right? And then you can take all those user accounts, and you can basically just try to guess a password against each one of them, right? So in this case, right, we tried winter 2018 against all the accounts I know of. We have a tiny sampling there, and the one at the top says that Amy admin has a password of 2018, right? So that's a thing that I tend to have, some level of success with. And the other thing that's interesting about this, right, is the way that people configure passwords, like within Active Directory, a lot of times is to set some kind of lockout threshold, right? You say, well, they can have 5 failed logons in a half an hour or something, right? And if their account gets locked out, in a half an hour, we'll unlock it, right? So that way we don't have to call like the admins and get them out of bed at like 2 in the morning to unlock somebody from accounting's, account, so that they can continue, doing their work or whatever off the clock, right? They just wait a half an hour and they can continue working. So what you have there is once you figure out what that window is, which you can also query, you can actually do a password spraying attempt each time that window expires, right? And if you know that their lockout threshold is something like 5, maybe you can try 3 passwords per lockout window, and they still have 2 failed logons during that time, right? So it kind of scales a little bit depending on the environment. My typical rule is usually I'll do like 1 password spraying attempt in the morning, and then 1 at the end of the day, right? Like depending on, and when I do that, I've never had a client say, oh my God, you just locked out a bunch of our accounts, right? Like it typically doesn't bother them. Like if you're paying attention, you might notice that you just had, 3,000 logon attempts from 1 IP address, and it was everybody in your environment. So like your SIEM or something like that can catch things like this, but it's definitely something worth paying attention to. Another thing that's kind of interesting about this, as an aside, is it works against things like Outlook Web Access, right? It works against things like Skype for Business, right? Which is pretty cool. So you can do stuff like that from the internet too, right? Or if they have any kind of like internet-facing, system, any kind of web portal or something, SharePoint, something like that, you can actually try this kind of thing from the internet too. So you're not necessarily limited to doing this on the local network, but that's sort of the context that we're talking about it here in. So let's say, that you get local admin access to a box, right? Like what can you do? What does that gain you, right? So one of the things that we've kind of already talked about is the idea of hashes, right? The idea of you can gather these hashes, you can crack them, you can gain more information about the passwords in the environment, and so on and so forth. So that's one of the things to kind of keep in mind, right? But there's some other things. You can also scrape memory, right? So if you have admin access to a workstation, you can get system level privileges. You can start like digging into memory. There's actually a tool called Key Thief, which can steal KeePass database credentials, right? So if you get on, KeePass again is a sort of a password safe, right, that is pretty popular overall, and you'll have groups of admins will store, a bunch of shared account passwords and things like that in KeePass, right? And they all sort of have creds to this KeePass database, and they can all, we got to pull up the service account password for this, or we got to pull up the shared, domain administrator account or something like that, right? They all get stored in this centralized credential store. Key Thief can dump that for you, right? If you're on a box, where your admin has KeePass open, its password is in memory, right? So if you look here, the top window, let's pretend, is like an attacker's command prompt, and the bottom window is the administrator's instance of KeePass, right? It's open, he's using it to get like really important passwords, right? So what you can do is you can literally, like once you have, you know, system level rights or admin rights, you can run get dash KeePass database key, right? And you just run this PowerShell, and it will take its sweet time, apparently, and eventually it will spit out the password. And in this case, the password again was king123 because I was lazy when I was making passwords. But so it pulls that plain text from memory, and if we lock the database here, just for the sake of locking it, and then we try to open it, we can punch in that password. I can apparently punch it in very slowly, but I can, right? And if we click the little display icon, I believe it shows that that's the password I'm putting in here, and you hit OK, and you can open it up. So that's kind of cool. I've had good luck with that in environments too, like as a means of sort of gathering further information about, you know, that environment and sort of learning additional accounts and pivoting into more secured areas or more sensitive areas of the network. Another thing I wanted to touch on here is network-based attacks, right? When you have admin level credentials on a system, you can start to do things with packets on the network, right? So Kevin and Travis gave a talk at the first meeting where they talked about this tool called Responder, right? That can do network-based poisoning, right? It runs under Linux, and you can poison link local multicast name resolution protocol. You can poison NetBIOS, right? Name resolution. You can poison WPAD. So as a quick refresher, like LLMNR and NetBIOS are just ways that Windows will resolve host names on the local network. WPAD is a means of configuring automatic web proxy. Like if you need to tell all of the workstations in your environment that they need to use this specific proxy, you can feed them those credentials via WPAD. They have a talk about that. It's on YouTube. You can watch that if you want more details about that, right? But I thought it would be cool to mention this tool called Ingve, which basically does the same thing from Windows via PowerShell, right? So again, using the capabilities of .NET. So like if you went to the last talk where they did that, and you saw that, we were like, well, they'd have to have this Linux box and run this tool, you know, that would be super non-standard. Like at the end of the day, this can actually all be done, you know, using PowerShell as well. So if you look at on the window on the right, I kind of cheated a little bit here. I ran Ingve, and then I didn't actually make it poison anything. If you look on the window on the right, we have a file share, and you'll see there's a bunch of files, and there's like a file called grievances and some merger information, right? And if you click on more files, inside of there is that malicious like link file that I made earlier, because I wanted to demo what happens when you open the folder. So this is listening for those authentication attempts. So I figured, hey, there's the sneaky link file. We'll just use that to sort of cause that hash to get sent. So if you look over on the left, you'll see that the user actually, admin, you know, attempted to authenticate to our Ingve instance, right? But you could also do, you know, network level poisoning, right, to cause sort of systems to send stuff to you. Like if people are trying to communicate, like fat finger a server name and the server doesn't exist, you get to be that server, right? So Ingve can do that sort of thing that Responder does. And if you want like more detail about those Responder pieces and kind of how those attacks work, their talk, it does a really great job of talking about that and sort of covering it in more detail. So I opted to sort of breeze over it here. So one of the things that's kind of cool, again, kind of local admin, right? Once you have local admin, you can dump those local credentials. And I sort of keep touching on this, right? But I want to kind of close out the talk by just kind of going over this idea, right? And sort of solidifying this a little bit, right? So we can start to look at ways to do that, right? And one of the things I like to do for this is to use something like Metasploit. It's just a really easy tool. I don't actually use Metasploit a lot for exploiting things. Like I know it's really well known as an exploit framework, right? And this idea of, you know, sort of popping shells via, sort of vulnerabilities in code, but I find it really useful for managing credentials. Like if I'm doing a large test and I've got like 300 credentials, right? And I have to figure out how to oh yeah, what credentials do I have again, right? It's got a database of credentials. It lets me do like password spraying attacks. It lets me also like running tools that are built into it, things like Meterpreter and stuff like that. You can dump credentials from memory using what's called Mimikatz, and you can do things like hash dump, right? So those are the things we're going to kind of talk about a little bit here, right? Mimikatz is a tool that abuses this ability of Windows, or this feature in Windows, to store user credentials in plain text. So like when you log into Windows systems prior to Windows 8.1 and Server 2012, it stored your credentials for your logged on user or any logged on user accounts in this wdigest form. It was in plain text in memory, and that was used to sort of facilitate single sign-on, right? So what Mimikatz did, Mimikatz is a tool that would go and it would scrape through memory and it would pull out those credentials, right? So as an attacker, like you no longer have to figure out how to crack those hashes or how to really deobfuscate them, because you have the credentials, right? The plain text creds, and you can take them and you can do what you will with them. It's a real nice time saver from an attack standpoint, right? So the wdigest issue is actually patched. Again, Server 2012, Windows 8.1, they patched it, right? So it's not there by default. They actually pushed out patches for Windows 7 and Server 2008 as well. And there's a link right there to the sort of patches for that, right? So if you haven't applied them. However, Microsoft does this awesome thing with backwards compatibility, right? Where they don't want to break anything, right? And I guess that makes sense to me. But there's a registry key, which is listed here. And if you set that registry key to 1, it doesn't, okay, the registry key doesn't exist to begin with, right? But if you make that registry key and you set it to 1, it actually re-enables the wdigest storage, right? So the next time somebody logs in, you don't even have to reboot the box, but wdigest will cache their password in plain text again. So like if you're suddenly you're in an environment and you get access to like a Windows 12 box or a Server 2012 box or something, right? You can change this credential, or you can change this registry key, and then you wait for an admin to log back into this box, and their password is then stored in plain text to wdigest, and you can grab it from memory, right? So that's kind of cool. So one thing that might, be kind of interesting is you can look at that key. There's a command right there for just a registry command, and you can set it to 0. If you set it to 0, that means it's not backwards compatible. So it's like if you were to set that to 0, you could, use some kind of FIM or some registry monitoring software, sort of watch that key, and if it ever changes, you might be like, we should go look at that box, right? Like that's weird. Like we didn't expect that. So that's one thing you could do to kind of catch attackers, right? And then so the last thing I want to talk about again is kind of like on this sort of hashing piece, right, and this password piece, and what you can do with domain admin, right? We already talked about how NTLM hashes are stored on local workstations to allow local accounts to log on, right? But if you have AD admin access, if you've sort of pivoted through the environment and eventually got like an Active Directory domain admin account, right, like our SQL Server account, right? Or another like common culprit that I find is like the SCCM account, right, that people use for like System Center Configuration Manager to push updates to everything, tends to be a domain admin as well. So you can sometimes use that to get into stuff, right, because that hash or that credential ends up on all of the boxes that it touches. So in this case, right, if you dump, we're going to use Meterpreter here. If you dump, we're on domain controller 1, DC1. If you do hash dump on this box, you'll get the NTLM hash for every domain user, right? Like in the Windows environment, because that's what's used, to log in. It's what's used to encrypt that portion of ticket granting tickets and things like that, right? So it's really important within that environment. You can get all of those for all the users, and you can start to do other things, right? Like you can start to crack those, right? So if you are able to crack a bunch of those, you can then start sort of doing variations on passwords you've already cracked against the remaining hashes to try to crack more until you get, an account that can get you to whatever information you want. You can also do this thing called pass the hash, right? Pass the hash is an attack that's been fairly publicized, but it's kind of, there's a little bit of like misinformation around it, right? Essentially how it works is you can log into something without knowing the password. Like once you have this domain user hash, right? You can actually just pass that along to a system as your means of authentication. There are plenty of tools that will do this. Metasploit by default will do it, but there's a bunch of other stuff that will also accept hashes as its means of authentication. So in this, oh yeah, that one. Well, there, my demo is working super good. It's like the one time it didn't work. Huh? Let's see if I can get it to run. Oh, I missed it. Maybe. Let's see. Oh, yeah, there we go. Okay. So essentially here we're logging in as the administrator user with password 1, right? That's its super secure password. And then we're changing the password from password 1 to the NTLM representation of password 1. And we're just authenticating with that. We're passing that hash to log in, right? It doesn't work for every service, right? So it only works for services that allow the hash to be passed, right? So some web services will allow this, right? Or SMB is a really common service that will allow that, right? So the Windows file sharing piece will allow this, right? But you might need to crack those if you need to, say, have the plain text password because you need to log into, say, like some third-party service like Jira or something like that, right? You would actually need to know their like plain text password to do that. So password cracking comes into play there. But one of the interesting things about like pass the hash and stuff like this, right, is with services like SMB, right? Like with remote desktop or something like that, right? You can do things like two-factor authentication, right? But with something like SMB, you can't really do two-factor, right? So that's a way that you can actually execute, you can log into a system over the share, and you can execute commands using a single factor using just this hash, right? Even if you can't figure out what that admin's password is, you can still carry out actions as them on a remote system over like SMB. And I've had instances where like, you're testing a company and they've like locked down remote desktop and they have like two-factor and all this other stuff, but they happen to just allow like SMB between these two environments, right? For file transfer and stuff like that. And that was, the means that we ended up using to sort of pivot between those two zones and get, further access to things and eventually get to, the data that we cared about and sort of the goal of the test, right? So again, like there are a couple limitations around this, right? It only works with services that allow you to pass a hash instead of a plain text credential, and you can mitigate it to some extent, right? You can deploy Microsoft's local admin password solution again, right? Because if you have that local admin hash, right, at least for the local admin user, it's only good on that one workstation, right? Another option you would have is a group policy setting called deny access to this computer network, right? So if it's a local admin account, right, that you use for those break glass scenarios, you can say, I'm not even gonna let it log in over the network, right? Like we're only gonna use this account when we're like at a console or we're physically at a box, like fixing this sort of like really, when everything's sort of gone topsy-turvy and it's a last ditch effort to like sort of solve whatever problem that is, you have to be at the box or kind of, again, like over some VMware console or something, so that you can't actually send this stuff over the network. So that's an option there to kind of help mitigate some of that. But it's really, at the end of the day, like pass the hash is kind of one of those things that's probably going to be there for a good long while at least. You probably can't totally eradicate it.
Feature.
It is a feature. It's an awesome feature. So that was kind of a lot of content, and I kind of bowled through a bunch of it because I didn't want to keep you guys standing here for, or sitting here for like 2 hours while I just like prattled on. But I tried to go through a survey of some methods of escalating privileges, gathering credentials, right, and sort of talking mostly about like attacks that are available to all levels of attacker. And what I mean by that is not like necessarily even their like privilege in an environment, but the fact that like everything I showed here isn't like something you have to be super elite to do, right? Like you can literally pull down all this stuff from like GitHub and do it, right? So that, to me, that's really important in the sense that it shows you that like an attacker has like basic capabilities and here are these things, and you don't even have to be like very intelligent or very knowledgeable to pull off all the stuff I just talked about here, right? Like you have to know that it exists, but like the actual sort of the ceiling for actually accomplishing it isn't as high as you'd think, right? Attacks always sort of start at some point. They move in an opportunistic manner, right? When people talk about advanced persistent threat and things like that, they always talk about the idea that your threat is really only as advanced as it needs to be for an environment. And what's interesting is a lot of this stuff in a lot of environments works really well, right? The stuff that I just, like commodity tooling, that's out there. So that's something to think about, right? And there are ways you can sort of mitigate some of this stuff or do logging to kind of help with it or alerting. So like just to take a step back, right? One path that might have existed, say in this tiny environment that we used for a demo here, would be like you start with limited access as the T user account, right? And you do a Kerberos attack and you get the SQL Server accounts TGT and you crack that. And then you have the service account password, right? And then you can move from there using that credential onto the domain controller and gather all of the credentials for all the domain users. And then at that point, you can sort of figure out what you want to do or what user credential, you need to get where you need to get. Or maybe you have rights to just give yourself an account that has access to whatever data you care about. Again, depending on the environment, depending on how well it's monitored, right? At the end of the day, like, this talk was focused on credentials, right? And the idea of like gathering credentials and finding that information so that you can kind of do interesting stuff with it. But the goal of like attackers, the goal of like pen testing and things like that as well, is not to get like domain admin in an environment, but to like find some kind of gem of information or something that they care about or some accomplish some ultimate goal that's going to further whatever they're trying to do at the end of the day. So domain admin might not even be necessary for that, right? They might just need to get like some particular account that can get all the users like payment information, or can get all their healthcare information or something like that, right? Their insurance information, things like that. So you'll find stuff like that. So definitely don't focus just on like, they got domain admin or something like that. And I didn't want that to necessarily be the focus of this talk either. If you have any questions, I'm totally game for questions. As a bit of a wrap up, I work for a company called Sikich LLP. They're based out of Chicago. We do pen testing, we do PCI assessment, we do risk assessment stuff, we do forensics. If you're interested in any of that, you can email me at samuel.gibson@sikich.com. If you want to hit me up with like regular questions, right? You're not like super interested in getting like pen testing done or something, or you don't need a forensicator, right? Like my personal email is samuel@surgicalmittens.com. You can email me if you have questions. And I'm also often in the EC InfoSec Slack channel, so I try to be responsive there when possible. Thank you for your time.
Questions for Sam?
The developer behind McCats recently released a new feature. Curious if you've used it. It allows you to do domain controller spoofing.
So that's DC Shadow?
Yeah, to exploit the trust relationships for like when large corporations merge. And instead of saying, well, you have to get rid of all your infrastructure and join ours, they just say, these two domains are now trusted. Mm-hmm. Have you done anything with that or used it at all?
I have not. I've not had an opportunity to use it yet. I haven't had an opportunity to play around with it yet. I did see that it came out. Domain trusts are interesting and they're complicated. In a nutshell, one of the challenges with like domain trust, right, is this idea that like as long as that trust exists, you can kind of abuse it as an attacker. And So yeah, that creates like a complicated sort of situation. But I haven't actually used DC Shadow yet. I've sort of looked at it a little bit, but I haven't like dug into it at this point. It only was released very recently.
There you go,
yeah. Cool. Have you played with it?
Only in the lab.
Cool.
But, yeah,
nice.
I mean, it's a cool tool, but it's just there's only like so many places that you'd actually want to use it or be able to use it.
Right, like where you actually have like all those trusts, right?
Yeah.
Yep. Yeah, because it's kind of the exception and not the rule.
Yeah. And a lot of the trusts will only go one way.
Mm-hmm.
So you can trust like up, but you can't trust down. So.
Cool. I'll definitely check it out. It's on my radar of like things to do. Anybody else?
Any other questions? Yes. Just pass the hash work to be 3.0?
Ooh, I don't know. Actually, that'd be interesting. I'd have to look it up. Anything else?
Is there another one back here? Other questions? I've got one. So since passwords are so important, how many companies, you do a lot of pen tests, obviously. Of the companies that you pen test, how many would you say do, lapse, good passwords on the admins and have a good password complexity requirement?
I would say that my experience is it's in the minority, right? And, excuse me, I think there's sort of challenges with that, right? There's sort of organizational resistance against doing something like that, right? Or depending on their sort of compliance mandates, right? They have concerns about the idea that there's like plain text credentials stored somewhere, right? And maybe their like auditor or something is gonna freak out about that. So there are some issues there, right? And there's a level of sort of comfort that comes with that. But I would say that using labs, at least in my experience at this point, is still kind of the exception, not the rule. We try to push our clients towards, something like that, something where they're not using that same credential on systems, on all of these systems, because it tends to be, sort of that soft, gooey core of a network, and it does create problems. But there's always kind of that pushback. So it like I said, it really depends. It depends on the company and kind of what they want to do. Anybody else? Yes, sir.
Have you or anybody else done any work on like a smash and grab kind of thing with a laptop that's sitting in the car, gets stolen, and it's unencrypted? If a user logs in with domain credentials, those are cached. Have you done any attacks, or is there any attacks against something like that, where there's a local database of passwords of some sort?
Sure. Yeah. So what happens there? There's another type of Windows hash. They're called cache domain credentials or something like that, right? So those are actually one of the few hashes that Microsoft actually salts. So they're slower to crack, right? If you can gather those off the disk and you can try to crack them. The other thing is if that laptop is unencrypted, it also, if there's a local account, right? If there are local accounts there, they're going to have NTLM hashes as well. Right, so those are potentially useful. You can also pull any kind of configuration files there, but yeah, you can actually try to crack the cache domain credentials as well, because you would have access to sort of the registry hives that contain all that stuff, right, and that password store.
I'd first of all ask you why you're smashing and grabbing anybody's laptop.
We've had it happen a few times.
So you're not grabbing anybody's laptop.
I'm personally not grabbing people's
All right.
laptops. Check your cars on.
Full disk encryption is a good idea, right? That helps, right?
Yeah.
Desktop helps too.
Depends how intense their smash and grab game is, right? Anybody else?
What's the most common way you get onto a box in the first place?
A lot of times it's weak credentials, right? If you're able to, get access to an environment, right? A lot of times once you start enumerating users, you can usually find somebody with cruddy credentials, right? Unless the company is doing something like requiring 15+ character passwords or something like that, But otherwise, there are obviously attack vectors like phishing and things like that too. But if we're talking internal testing, say you have a Dropbox in there, a lot of times weak credentials work, or network, poison the network, right, with Responder and things like that are also hugely popular and very effective.
Do you prefer being on site for your pen testing, or do you enjoy the thrill of the hunt from off site?
It's a mixed bag. I don't travel much for work. I travel about one time a year for work. I mostly work from home, which is nice because I get to eat lunch with my family and stuff like that, right? And my wife is not a super huge fan of me traveling frequently, so that's kind of nice. But at the same time, I like people. I like to meet people. It's nice to put faces to names. So I do genuinely appreciate when I get to go work with a client and sort of see them face to face, and and get to know them a little bit better, right? It's a little more personal. So.
So have you seen like an uptick in vulnerabilities with more like customer-facing or open-facing services such as like Web Outlook, or where you can use that to password spray? You can find a list of the users and use that. Do you think that's made it easier, or?
So it kind of depends on the company, right? Some companies will, depending on their vertical, right, they might, or depending on sort of their goals, they might just publish a bunch of information about their users, right? I've tested companies where they had, you know, an entire directory on their website of like, this is everybody who works for us, right? Because they want all their staff to be able to be contacted by potential customers, right? Or like universities will publish lists of all their employees, right? Because they're sort of like, they're all in public domain, and they want people to be able to find like everybody in this department or that department. So again, like it kind of depends. If I'm able to say, you know, like scrape a bunch of LinkedIn profiles or something, I might be able to figure out people's email addresses, right? And I can maybe pull down some documents and look through metadata and figure out how to take, you know, their usernames and turn them into, or, you know, their actual names and turn them into whatever username format is in, you know, those documents. It really depends on kind of the way that, you know, the way that reconnaissance works and the way, or how well reconnaissance works and the sorts of things that they expose to the internet, right? The things that I'm able to gain access to. Typically, if you're able to get enough user accounts, right, and you're able to say, you know, find some kind of interface like Outlook Web Access or Skype for Business or something like that, right, or some kind of web portal that you can log into, you know, or a single factor VPN, yeah. If you have enough accounts and they're not like, you know, doing something that requires sort of people to choose passwords that aren't things like winter 2018, you can typically, you know, gain access to some kind of resource via that type of method. Does that answer your question? Mm-hmm. Cool. You like my it depends answer? I'm good for those.
What about companies that are moving towards PC as a service, like the thin client stuff, PC over IP?
Mm-hmm.
How does that affect your game? Like a lot of small businesses don't even have domain controllers.
Okay. Yeah, actually, right. Or they do like Active Directory federated services or something like that. Yeah, I mean, it kind of depends. I haven't had to do a lot of testing of environments where they're doing like thin client stuff, so I can't speak a ton to that. But like for federated services, you know, you still end up with like some ability to, you know, gather that information. There's something there that's like, you know, federating that locally. So my experience is it hasn't changed it necessarily wildly, but it just kind of requires you to think about it a little bit differently.